Well, hello 3C, and welcome to the first lesson of your next unit. We're just kind of taking off from where we left off in the last unit. We're talking about forms of quadratic functions. Now, in the last unit, we only talked about vertex form, but here we're going to talk about some other forms. So our goal is, I know the three forms that a quadratic function can be written in, and what information can be taken directly from the equation for each. So let's have a look. I've got three different equations here, and the first thing that I'm going to do is show them to you on a little online graphing calculator. So here are my three functions that I'm going to show you, and I have them shut off right now. That's why you can't see anything graphed on this grid, but I'm going to take a look at them, and I'm going to turn them on one by one. So here's the first one. Okay, you've seen that one. I'm going to shut it off, turn on the next one. Oh, and there's that one. And we'll shut it off and turn that one on. Oh, and there's that one. Did you notice something? If I turn them on all at the same time, why won't that there when that one's turned on? I just get this kind of gray line here that's combining both the red, the blue, and the green because they're all exactly the same parabola. Notice that they're written differently, but they're all exactly the same. So here are the three forms. What did we notice? Here's what we noticed. Whoops, better take let's get my little arrow here. Here's what we noticed. They all represent the same parabola. So this one over here, part C, this is the one that we're familiar with. This is called vertex form. And here's the general form of it, a bracket x minus h squared plus k. This is the one we were working with last unit. Now we've got two other ones here. This first one is called standard form, ax squared plus bx plus c. And I'm just going to point out to you that in this form, this a would be the same thing as what's in front of x squared. And since there's nothing there, we would say it's 1. So in this case, our a is 1. Now our b is what's in front of the x. So here, our b would be a 2. And the negative 3 would be what corresponds to the c. There, c. Okay. So in vertex form, up here, and I'm just going to go back what we had before, our a value, there's nothing out in front, so we would say that it's a 1. Inside the brackets gives us our h, so this is our h. And on the end gives us our k. Now remember, the h value in here that we learned last unit, that h value has a different sign. That's what's in here. See, this one's a plus and this is a minus. This one would actually be minus 1 for our h value. Now the last form we have here is called factored form, and we say that that is in the form a x minus r x minus s. And so here's what that means for this one. It means that we have nothing out front, so our a value in this case is a 1. And notice how I've got this negative sign in here too. That means it's going to change my signs on me. So the r value for this one is negative 3. Okay, because it's a positive up here, so it's a negative down here. And our s value in this case is going to be a positive 1. Now, let's graph it on here. I'm going to graph it using the vertex form because that's how we learned to graph it in the last unit. So in vertex form, this tells me that the vertex is negative 1, negative 4. So negative 1, 1, 2, 3, 4. There is no a value, and we know that it opens up. So I'm going to go over 1, up 1, over 2, up 4, and over 3, up 9, which would put me here. And I think that's about the best I can do, so I'm going to try and draw a nice parabola through it. And we want to see what kind of information we get out of here. Well, the vertex is, as we picked out before, it's negative 1, negative 4. Okay. Opening, well, it opens up. The axis of symmetry, remember, it goes right down the center of the parabola, right through the vertex point. So we say that it's x equals whatever that vertex point is, negative 1, or the x-coordinate of the vertex is. Does it have a maximum or minimum value? Well, since it opens up, it has a minimum value because it has a low point. It's opening up, so when we go up, it gets bigger and bigger and bigger, but it does have that low point. So it has a minimum value, and that minimum, the lowest that it ever gets to, is -4. Now our x-intercepts here are right here. There's a 1 and -1, 2, 3. So a -3 and a +1. And the y-intercept, well, the y-intercept is right here. I'm going to pick a different color to circle that one with. There's our y-intercept where it crosses the y-axis, and that y-intercept is -3. Now, I'm just going to point out that all of these numbers we saw just in the equations that were up here. So this -1, -4 came from vertex form, -1, -4. Opening up is because that a value out front, and this is in all of them, the a value out front is positive. There's no negative. If there was a negative, this would be turned over. Axis of symmetry comes straight from the vertex, x equals -1, and the max or min value comes from the vertex point, on this one -4. So here's the two things that are new to us. The x-intercepts, where it crosses the x-axis. And that was here where I circled those two things. But we've seen those numbers before. They were in factored form. This is actually the r from factored form, and this is the s from factored form. So I'm just going to put in brackets here that we got these from factored form. That's no coincidence. Will happen every time. And the y-intercept is -3. And here's where we saw that one was right here. And that is not a coincidence either. This comes from, you can pick this out of standard form. So let's have a look. What's this say? Which properties is each form useful for finding? Well, this one, standard form, gives us the y-intercept. And the y-intercept is the c value on the end, or in this case, -3. Factored form gives us the x-intercepts. And the x-intercepts are r, which in this case is -3. Remember, we've got to take the opposite sign that's there. And s, which is +1. Again, we have to take the opposite sign from what's in the brackets. Now, the vertex form gives us the vertex, and the vertex is going to be this and this, which is going to be -1. Remember, we've got to take the opposite sign, and -4. It gives us the axis of axis of symmetry. I'm just going to say axis of s. We get that straight from the vertex, so x equals -1. And it gives us our max-min value. Max-min. In this case, it's a minimum. And that value, it comes straight from the vertex. The lowest it possibly gets to is -4. Now, there's one thing that all three of these give us, and that is the stretch factor. A is in all of these things, and in this case, it's just 1, so there is no stretch factor. So all of these things you can actually see the stretch factor for. And also that a value tells us it's opening. Because if the opening is greater, or if that a value is greater than 0, and if it's positive, it opens up. And if it's negative, it opens down. So since that a value gives us up or down, we also get it from each of these. And notice that we used an a in all three of these equations. That's because it's actually the same number in all three equations. So let's take a look. Here is a standard form. So this is written in standard form. I know that because there's no brackets at all for the whole thing. Direction of opening, well, to get the direction of opening, we got to look at the a value. Since it is negative, this opens down. And opens down because a is negative. Does it have a max or min value? Well, since it opens down, it looks like this. it's got a high point. A high point means it has a max value. Do we know what it is? No, we actually don't, because I don't know what the vertex is. In this form, I don't have the vertex, and I need the vertex for that max value. But I can tell you it has a max value, I just don't know where it is. And the y-intercept, remember we can get the y-intercept from here. The y-intercept is -7. And this is our c value. So this gives us our y-intercept, and this tells us the direction of opening. It also gives us our stretch factor, but we can't graph it unless we know where the vertex is. Now, what are the x-intercepts of this thing? Well, if you remember from what we did before, these two things are the x-intercepts, except that since they're in brackets, they've got a positive, or we've got to change the sign. So what are the x-intercepts of this one? Well, there's two of them. There's -6 and there's +4. Use the x-intercepts to locate the vertex. Now I'm going to give you a little bit of information here. If I've got this parabola and I've got x-intercepts at here and at here, so let's say that's at -6 and +4, although it doesn't really look like it, the x-axis of symmetry, which goes right down the center through the vertex point, will be right smack dab in between those because of symmetry. So all I have to do to figure out the x value of the vertex is take the average of those. I'm going to take -6 + 4 and divide by 2. I'm just taking the average of that. Well, -6 + 4 is -2 over 2, which gives us -1. Okay? So the x-coordinate of the vertex is -1. So I know that the vertex is -1 comma something. Now I have to figure out that something. This is the y value of the vertex. I don't know what it is. However, I do know that for all x's, y equals x + 6, x - 4. So I'm just going to use what I have for x here and now figure out my y. So I'm going to put -1 and add 6. That's not a -1. Let's erase that and try and write -1 again. -1, and we're going to add 6. And then I'm going to take -1 and subtract 4. Now let's do the math here. -1 + 6 is 5. And -1 subtract 4 is -5. Well, 5 times -5 is -25. So now I have my whole vertex. My vertex is at -1, -25. So that's how to use the x-intercepts to find the vertex. Okay. What is the y-intercept? Well, the y-intercept occurs, let's actually do this sketch again. Here's my y-intercept. My y-intercept is down here. Now, what do I know about this point? Not much, except that x is going to be 0, because this is the 0 line for the x when it crosses the y-axis. So we're going to sub a 0 in for here. So we're going to say y equals 0 + 6, 0 - 4. That's pretty straightforward, because this is just going to be 6 times -4, which is -24. So the y-intercept, and there's only one of them, is -24. And that puts an end to this particular lesson. Bye-bye.